Welcome to the deep dive. So, if you're just starting your journey into cloud computing, specifically with Amazon Web Services, you're really standing on the edge of something incredible. Limitless possibility, but also, potential catastrophe. We're looking at a stack of sources today that are all about that really crucial early learning curve.
It really is. It's arguably the most powerful tech environment a beginner can even touch. You get access to what feels like infinite global computing power just right out of the gate.
Yeah.
But that power, it comes with a demand for discipline, a very specific kind, which is why beginners so often run headfirst into some really serious trouble.
And that trouble, in our experience, it pretty much always boils down to two things, right? And they are, well, they're equally devastating. Either it's a major security breach that just compromises everything you have, or you get that surprise bill from AWS that is so big it makes you question every single life choice you've ever made.
Yeah, that's the one. So our mission today is crystal clear. We want to give you a shortcut, a way to get to safe, responsible usage. We're going to dissect the top 10 AWS beginner pitfalls and, more importantly, their fixes. We're not just naming the mistakes.
Sure.
We're giving you the exact steps to avoid both the security nightmare and, the budget disaster.
Exactly. And we've grouped them into three logical areas. First, the four immediate security traps, then three big cost catastrophes, and finally, three sort of operational and architectural issues that really separate the novice from someone who knows what they're doing in the cloud. Okay, let's unpack this and start with the most critical part, because if you get this foundation wrong, the whole thing is just unstable. This first segment is all about locking the door.
Pitfall number one, and this is truly the biggest initial security mistake we see. It's root account misuse.
The root account. So this is like the single master key that opens every single vault in the entire kingdom. Why do beginners default to using it for everything? For their daily tasks? And what makes that so dangerous?
Well, they use it because it's easy. It's simple. When you first sign up for AWS, that's the only account you have.
Mm.
But that ease is, it's really the enemy of security here. That root account has ultimate unrestricted privileges. So if those credentials ever get compromised, maybe through a keylogger or a phishing email, an attacker owns everything.
Everything.
They can shut down your services, delete your backups, or
Backed
just
up massive charges.
instantly.
Yeah, that's terrifying. So what's the alternative? What do beginners need to do, like, right away?
The fix is absolute. You should only use the root account for, let's say, foundational setup, changing your support plan maybe, or for, an extreme account recovery situation. For everything else, launching servers, creating storage, managing billing, you have to create and use IAM users.
I am in identity and access management. That feels like a bit of a friction point for a beginner, though, doesn't it? Why bother creating a whole separate user profile just to launch one simple server? It just seems like it slows things down.
It creates vital boundaries. That's the key. IAM lets you practice what's called the principle of least privilege. You give users only the permissions they need to do their job, nothing more. So if an IAM user's login gets stolen, the attacker, well, they just hit a wall.
Yeah.
They can only damage the very limited scope of things that specific user was allowed to touch.
Not the entire account.
Exactly. That little bit of friction is the difference between a small incident and, complete annihilation.
And speaking of protecting that root account, that takes us right to pitfall number 2. It's still about that basic protection. It's neglecting multi-factor authentication, or MFA.
This is so foundational, and yet, statistically, it is still the #1 security oversight we see in new accounts. MFA on the root account is it's non-negotiable. If someone manages to get your username and password, MFA ensures they still need that physical or digital token from your device to actually log in.
It's the simple deadbolt on the door. It's the cheapest, fastest way to protect against, 90% of account takeover risks, and yet people just ignore it.
It takes less than 60 seconds to set up. But I think there's a psychological hurdle, right? Beginners think, oh, I'll do it later. But later usually means after they've had their first really scary security alert.
Okay, pitfall number 3. This one's a bit more of a modern development danger. It's less about the account and more about workflow. Hard coding credentials. We're talking about developers who store their static access keys right in their code. Or worse.
Oh, yeah.
They push that code up to a public place like GitHub. That's like putting your bank vault combination on a digital billboard.
And this is where the speed of modern exploitation gets truly horrifying. It's not that bots are just constantly scanning public repos. They're scanning them in real time. We're talking about keys being found and used to launch expensive Bitcoin mining servers within minutes.
Minutes.
Sometimes seconds of being posted. It's that fast.
That instant speed just makes those static keys toxic.
Yeah.
So what's the best practice? What's the solution for, say, an application running inside AWS that needs to access other things like a database?
The solution is to just stop using static, long-lived access keys completely for things running inside AWS. Instead, you use IAM roles. This is a huge mental shift. A role gives temporary, restricted permissions to an EC2 instance or a Lambda function. The service itself automatically handles the secure rotation of those temporary keys, which means you never, ever expose a static credential that can be stolen or pushed to GitHub.
Ah, so the permission is tied to the resource itself, not to some secret piece of text you have to copy and paste around.
Exactly. It's a much safer model.
That's fantastic. Temporary rotating access is infinitely better. Okay, moving down the stack a bit, let's talk networking. This brings us to pitfall 4. Wide open security groups, specifically that really dangerous configuration of 0.0.0.00.
Yes. This is the classic beginner mistake, and it's usually born out of frustration. A security group, it's basically a virtual firewall for your servers, for your EC2 instances. A beginner is trying to get something running, and they just can't figure out why their connection isn't working. So what do? They set the inbound rule for a port, like SSH or RDP, to 0.0.0000 just to make it work.
The thinking being, well, if I open it to the whole world, it has to work, right?
Exactly. But what 20.0000 actually means is I will accept traffic from any IP address in the world on this port. And this isn't a theoretical risk. It's an immediate active threat. If you do this, you will instantly see thousands of malicious bots trying to brute force their way in every hour. Your logs just get flooded.
Wow. So you're compromising the instance the second you hit save. What's the simple fix?
You have to restrict access to only the specific IP addresses that genuinely need it. If it's just you from your home office, you put in your home office IP address, that's it. That level of provision is just the bare minimum for network security. Never, ever let 0.00 but 0.00000 neural management port.
Okay, those 4 security items: root misuse, no MFA, hard coding keys, and open security groups. That's enough to save most people from total disaster. But now, here's where it gets really interesting for the wallet. Let's shift from preventing breaches to preventing that dreaded bill shock.
Right. Section 2 is all about cost discipline. And we're starting with pitfall 5, which we call the silent killer: zombie resources.
It sounds ominous, but I'm guessing the reality is just sad, forgotten infrastructure. What exactly is a zombie resource?
It's the cloud equivalent of leaving the meter running when you're done with the job. A beginner will launch an EC2 instance, they'll test some code, confirm it works,
Sure.
and then they just close their browser tab or shut down their laptop. They forget that they have to explicitly go in and stop that instance. And while they aren't using it, it's still racking up compute charges, or at the very least charges for the storage and maybe an IP address attached to it.
So even if the server is just sitting there idle, you're paying for the potential. You're paying for the electricity you could have used. And I bet there's some confusion between stopping an instance and terminating one.
Oh, absolutely. Stopping an instance shuts it down, and you usually only pay for the storage that's left over. Terminating means it's gone, it's permanently deleted. Beginners think closing the console stops the billing, but that forgotten meter is just ticking away, day after day, slowly compounding the cost.
That slow drain is awful. And it's always made worse by pitfall 6, no financial early warning system. What's the simple step people skip that leads to that giant career-questioning surprise bill?
They don't turn on the free monitoring tools that are designed specifically to prevent this. I mean, this is just negligence because AWS gives you the tool for free. The fix is to set up AWS budgets or, at the bare minimum, CloudWatch billing alarms the moment you create your first resource.
So you're saying these are automated notifications, not just reports you have to remember to check?
Exactly. They are automated alarms. You don't have to manually audit anything. You go in and you tell AWS, email me immediately when my spend hits $50. Or even better, alert me when my projected spend for the month hits 80% of my limit. If you skip this, you only find out you have a problem when that final bill hits your inbox a month later. It's the only way to catch a runaway server before it enters your bank account.
And so often that bill is inflated for no good reason because of pitfall number 7, over-provisioning.
This is pure resource waste, and it's driven by anxiety. Over-provisioning is when you pick a massive server, like a 16-core machine with 128 gigs of RAM, for a simple website that A much smaller, cheaper version could handle perfectly.
I think beginners feel like they need that buffer, right? They worry that if they start small, they won't be able to handle a traffic spike or they'll have to rebuild everything later on.
And that anxiety is a complete holdover from the old world of physical data centers,
Hmm.
where upgrading hardware took weeks and involved downtime. The whole point of the cloud is elasticity. AWS lets you start small and scale up easily, often with zero downtime. So you never provision for your distant potential. You provision for your current need. And you trust that you can scale up when the actual data tells you to. Starting small respects your budget.
That's critical advice. Okay, let's move to our final grouping. This is about the strategic decisions, the operational habits that really separate a beginner from a confident, cloud-savvy user.
Right. This takes us into the mindset pitfalls, starting with number 8, the lift and shift mentality.
Okay, so you're defining an architectural blunder here. This is when someone treats AWS just like their old data center, right? Just replacing physical servers with virtual ones, one for one.
Precisely. The lift and shift mindset is just creating technical debt right from day one. You take your old server image, which needed manual patching, manual backups, manual network configuration, and you just drop it onto an EC2 instance.
Yeah.
You've replicated the server, but you've completely ignored the cloud.
So what's the cloud-native alternative then? Can you give us a concrete example of that paradigm shift?
The alternative is embracing managed services. Let's think about a database. In the lift and shift world, you launch a big EC2 instance, you install Linux, you install PostgreSQL, you configure replication, you set up monitoring, you manage backups. You are managing everything.
That sounds like a full-time job for just one big system.
It is. In the cloud-native world, you use Amazon RDS, the relational database service. You just tell it what database you want, what size, and you click deploy. AWS then handles the patching, the backups, the high availability, the underlying servers, all of it automatically. You pay a little more for the service, but you save so much in operational cost and time and human error. If you treat the cloud like your basement, you pay all the costs and you get none of the benefits.
That's a powerful distinction. You're basically paying AWS to take the boring, repetitive maintenance work off your plate.
Exactly. Use the cloud services. That's why they're there.
All right, on to pitfall 9, which is almost comical because the advice is literally free and personalized for your account. It's ignoring free advice, specifically the advice that comes from AWS Trusted Advisor.
It is honestly astonishing how often new users just ignore this. The Trusted Advisor is a service that checks your entire environment against best practices for security, cost, performance, and fault tolerance.
So you don't even need to hire a consultant or do a manual audit. The platform itself is constantly running checks and giving you a prioritized list of things you can do to save money or fix a security hole.
That's exactly right. It's a built-in safety net. It's your primary source of personalized recommendations. If you have an unused resource, it flags it. If you have that wide-open security group, it flags it. If you're underusing a big server, it tells you how to downsize. Checking Trusted Advisors should be the first 5 minutes of your day, not something you glance at once a quarter.
Finally, let's talk about pitfall 10. This is arguably the most immediately frustrating and, well, permanent mistake a beginner can make, losing the private key pair. We're talking about that .kim file you download when you launch a Linux server. What happens when that file is just gone?
The gravity of this, you just can't overstate it. When you launch a Linux instance, AWS uses what's called asymmetric cryptography. It puts a public key on the server, but the private key, that .pem file, is only held by you. It is the only way to log into that instance via SSH.
So if you lose that file, you are permanently locked out. There's no forgot password button in the console.
None. Zero. That encryption key on the server cannot be recovered or changed without its matching private key. Losing that file isn't like losing your house key where you can just call a locksmith. It's like the front door and the foundation just dissolve behind you. You can't log in. You can't get your data. Your only option is to terminate the instance and start over.
Wow. That is the definition of a critical operational oversight. You have to treat that file like you treat your bank account login.
Absolutely. Secure it, back it up. Losing it just stops you dead in your tracks.
We've gone through 10 major pitfalls now, spanning everything from, locking the front door to making sure you can actually afford to keep the lights on and log in.
The key takeaway, I think, is that the cloud is this instrument of immense power, but that power demands immense discipline. The line between feeling anxious as a beginner and being confident and secure is really just methodically addressing these 10 things. Use MFA, use IAM, set budget alarms, choose managed services.
It seems like the most common mistakes all boil down to these little friction points during setup, don't they? forgetting to click stop, or not wanting to use IMM because it's slightly more complicated. But those small things turn into catastrophic failures or devastating bills if you just ignore them.
The consequences are always disproportionately large compared to how simple the initial mistake was.
We spent a lot of time today focusing on avoiding that surprise bill and preventing the worst security breaches. But I want to leave you with a final thought to mull over. We highlighted the AWS Trusted Advisor as this free automated resource, and we focused on its cost and security warnings, which are crucial. But Trusted Advisor also gives you recommendations for optimizing performance and resilience. So the provocative thought for you is this. Have you checked those performance recommendations lately? Is that free advice actually being acted upon to improve the speed and the robustness of your systems? Or are those hidden efficiencies, those stability improvements, still just waiting for you right now in a report you haven't glanced at?